Hi everyone, my name is Aman Yadav and this is my component 5 video presentation for me the operating system module. In this video I am going to summarize all work that I have completed from 1 to 4. I will briefly explain what I have did in this component, show the screenshot of my work and then talk about why I learned overall. The main aim of this presentation is to show my understanding of operating system concepts and practical work. In component 1, here is the question. Here it just asks for the add sign in as UW GitLab as I have done here. Create a project on your GitLab account. To make a new project, I have login in the UW GitLab, and after that I have just login by my name, by username and password. And for this component, I have created the private repository on GitLab and learned how to create a repository. Here you can see the proof of repository, and repository name was OS Portfolio Aman Yadav. Then I generated the personal SS token. Personal SS token could clone the repository, and Ubuntu it helps to clone repository. This SS token has helped to clone the Ubuntu and UWE GitLab from the personal SS token and created and modified it locally. Here you can see the clone, and here is the cloning screenshot. For clone there is a simple code git clone and just paste the profile link, and in username, for username asked, and I have put here the username. For cloning from Ubuntu to UWE lab, there is SS token generated above. I have seen already in screenshot, and I have that pasted here. Then we can see there the receiving object is 3 by 3 done, so I have cloned this. Then I have created a repository. Already I have created the repository, but I have make the modified in component 1. First I have write this echo. This I have to write this echo component 1 submission readme student name student id. Then I have show that, for to show that cat is the command to look what you have write. Then after use git command and modify it. Here is a simple command. First I have made that assignment1.txt file, then I have git add assignment.txt, and simply I have modify it, and here you can see the cat assignment.1txt, and you can see the what I have modified there. First of all, in upper I have just kept my name id, that's it. But here when I have modified and I have kept the course name and level also I have mentioned here. After that, question asks for to push, then there is a simple code git push, and when I type git push and enter the certainly username and password has asked from me, that I have given the my username and password. In password place I have given the SS token. Then we can see the result. Our first component was pushed here, and here is the assignment 1 txt also seen. Here my work has been submitted, means pushed in my UW GitLab. And next question asked for me the fork for classmate. Here git remote called upstream is configured, and I have asked for my friend to give me the your fork link. Then then he provided me the link. Just there is a simple command also git removed and upstream, and I have pasted that link that I have asked from my friend, and simply here is the result. There is a simple command git remote b that will show you the your fork has been done already. So this is my component 1. Let's move forward towards the component 2. In component 2, this part was about C programming and understanding how the process work in Linux. Exactly that. Here is the proof and screenshot. First I analyzed fork and fork I analyze the two system calls that are fork and get PID. Simply the return value of a fork help to identify which part of was executed by the child, and get PID and also used get PID to print the process ID on the terminal. So to confirm that the relationship between the parents and the child process, I check the proc. Here is the proc. Simply here is the proc status. Then file system was verified by the PID. Here we can see in the screenshot. Here is the PID as I have done with proof. Let's move forward. Then in terms of the operating system OS structure, how PS and top fetch data for the Linux kernel. Here is the Linux kernel, how this component I have managed. When executed commands like ps stop in active process with their process ID, state the CPU uses, memory footprint, all running process dedicated toward the command line, and proc ID. When I have already mentioned, this proc ID contains the various files such as status, stat, command line that maintains the deadline information for the PID that I have already shown in screenshot. This is really helped me to understand how Linux multiple process and how operating system keep track to them internally. Let's move forward towards the component 3. This is little bit long and I have done the many work here. So first introduction part. This component analyzes the behavior of the command Linux commands like cp, cat, top, ps, and kill using the system call tracing tools such as stress. Stress plays the vital role in this component. The objective to understand how user level command style of the Linux command. The analysis focus the operating system concepts such as the process management, file memory management, and the internal process communication. Here simply I have the analysis the Linux command, that is system call read write open at execute. When we type the stress command, then we can see the disk of, and I have analysis each of them. First, here I have explained and I have shown the proof also. First I have make one file name txt1 test.test1.txt and I have analyzed them. The simply I have code here the cat txt test1.txt, and as we can see here the screenshot proof, and simply we can see the result also. This this shows the exeb open add and read nmap close. Here is the internal text file name is called created and modified. Then I read cat under the asterisk. After that, I already mentioned that the asterisk plays the vital rate. When I enter component 3 folder, this allow me to see the system call, and I have started the asterisk cat test1.txt. Then program starts, program installation. As we can see here, the exeb user bin cat. This means the OS successfully start the cat program and pass the text test1 as input, and break null. As we can see in the next line, this shows the setting heap memory that plays the vital role in allocation of stress. Then after I have searched for the open at this load requirement system. This means the cat opens the C standard library for the basic function, and here is equals to 3. What does this means? 3 means the Linux gave is the descriptor 3 and ID number for open file resource, read file content and print into terminal. And already I have that change. This is my first commit, name OS module OS, name Aman Yadav, sorry, and module OS that I have already committed. End of the file which shows the read 0. 0 means no more data. I have already cleared that, so cat stop reading and move forward the cp command analysis. Cp command copy data from the source file to destination file. Executive being such as the exv, close, copy, open at. Already I have told you that. Sorry, I have already mentioned that. And under this I ran the stress cp test 1. Simply that, already I have explained this. The trace begin with exv. Always stress is begin with exv and end with 0. This indicates that the OS successfully launched the cp program from user bin cp. Or return value of 0 confirms the program started with errors. And here the library and routine setup. cp loaded the necessary libraries. It is has started though this in the trace as. During this phase, calls like read, fstat, and nmap are read the information for the library, examine the metadata, map library code, memory improvement, and performance. Open source. Source file is shared with cp. Then we have created the open file destination will be copied from here. Then open at, this is the important role also. Open wrongly means open for write. O create means create the file that doesn't exist. O actually means fail already and exit the writing. Transport control from the source destination actual file transfer. Let's move towards the ps command analysis. As ps command displays the information concerning the running process, the data obtained from the proc value, as I have already mentioned in the component 2. And here is also the ps command. System call include the open at get pairs that directories to the environment. First I run the ps command and pu ps. When I just, you can see in screenshot ps, then they show my the pid, and then after pu aux, then it show my the real pid root and start. Then I run under the asterisk. Simply, already I have explained this exeb. Simply that like only. And in conclusion, this practical shows how the ps start using exeb then collect. Important one is top command. Top command often real-time system call monitoring. The process table includes the file PID, users, percentage, CPUs, and here you can see in the terminal as the proof of screenshot. Simply run the top and they give me the PID, users, PR, NI, VRT, percentage, CPU, time plus command. And again I have run the stress, as here is the proof. This indicates the operating system successfully starting the top process. 0 means confirms that program launched correctly. Loading the requirement system file and libraries. Top access system runtime files such as open at and read 3 means 832. This indicates the byte where read successfully installation. And another command, kill command analysis. Kill command uh, forwards singles the process after installing the kill system calls used to deliver a single such as. Simply I have generated the pid and just I have killed. Kill means when I have run in the background anything and keep the pid number. This is the command ps kill -9 and 2486, that will definitely kill that. 9 kill skills which forcefully terminate all process, as I have already told. And I run the stress under the kill also, and here is the result and screenshot. And read 3, here you can see the different from the others. Read 3 local name ls data. This means the process reads the configuration local related data into memory. And second, this value means the returning shows the end of the file location has been reached. And close 3 means code was closed successfully, your program was closed successfully. And here is the system call analysis using stress. There in cat test, and I have made this cat for my own command. This cat mainly do read, open, and write. Read, write, open. Here the exeb system Trace tool was used to trace calls generated along the Linux command. For example, tracing cat command shows the exb startup and br key. I run under the trace under this trace cat. Uh, then here you can see the full screenshot of this. Then I started successful memory allocation, means this one allocated the private memory and allocated the structure. Then the thread synchronization security setup, heap installation, means the calls manage the program heap first interview and current of the heap, while the second expand is allocated and dynamic memory. Then the read write close read, as already mentioned, and the process terminated exit group. Open operating system concept demonstrated. Memory management, file I open at read write close, kernel user space, process. Here is the Linux course code analysis, cat command. This part of the GNU control units, and I have worked in this very hard. This is cat mycat.cpp in a C language programming. Here I have written the program like top ls and like this in command. The custom command mycat follows the same basic approach but in simplified from the open single file. In read only mode, using the open read data in buffer, using the read and write data to standard the output write. Simply custom cat command implementation. I have implemented this command. The custom version of the command mycat was implemented in C low level language system call. This simply file using the open reads data and writes to standard output use. MyCat is this an operating system concept demonstrated in these three components shows the key components such as through the practical analysis interacting with Linux kernel ss file. Simply this cat command do read write open as close. And moving forward to the and I have already pushed here is the proof of that. I have already pushed this component 3 also. And in conclusion, this component demonstrates the detailed understanding of the Linux command behavior. And moving forward, the component 4, here is the buffer overflow, that simple explanation buffer run oriented program, heap explanation etc. Here is the brief explanation. Here is the brief explanation how in stack based the buffer overflow occur when the program writes more data and fixed size. Demonstrate this. Mm. For this module, I learned the several important things, system calls, and demonstrated this how I have created the component for this is a simply file. And the vulnerable C program contains the function with unsafe input operation scan f buffer, a hidden function secret function. And here you can see the cat bouncy. This is the buffer overflow code here, and code spanning print cell means this will keep the access the cell, and scan f means buffer. This will show the exactly what will happen in cell. Identifying and target address, an address of the hidden cell spanning function. Identifying here is the some binary and stack no pipe, and I have generated the secret function crafting and executing the exploit payload, padding the bytes to overflow the stack buffer memory address, and payload was piped into vulnerable and 32-bit. This vulnerable is 32-bit, and this is the simple code. And cell access, an exploitation program is rated was redirected and hidden function ruling. And here we can see a output. This is the command line, and I have entered some language and shows the congratulation. And here is showing that the spanning cell, this is the what exactly this component has done, and component has told to do, component has asked. And python 3 means run python command directly from terminal, write or raw bytes directly. This is the simply I've explained the commands lines, that 132 means what, pipe means what, and measured against the memory exploitation attacks. Several defense can prevent the significantly reduce and risks of the memory exploitation. There is also the safe coding practice. Use bounded input the function and f gates. Always specify input limits. Scanf, stack cookies, which always defends. And at last, here is the in last class, our body tutor has also taught that when you create on 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 command, then from you have to run from anywhere. So I have created this vim test1, vim test.txt. This file holds the following text. This shows how the cat command works. This custom commands my cat is then executed as my cat text, and the result displayed are exactly like what in the text.txt. Ensure it functional. Simply, I have gone in terminal and vim vim text.txt. After that, my cat.txt, this I have run and I have made the file file location change. Then after I have run this in a new terminal, and as we can see that I have just typed my cat test.txt. Then simply this shows the output. This is the test for cat command. Okay, the cat the my cat function implemented the linux cat command. This function carries out the following operation: will make the file name test.txt from command argument. This simply makes and use of the system calls such as open, read, write, and close. I have already mentioned before also this, and I am concluding all this. To conclude, I have completed all four components and demonstrated my understanding through this video presentation. This coursework gave me hand-on practical knowledge and experience with real operating system concepts from basic to advanced, and from the process creation to the kernel interaction security. Thanks for watching. Thank you, my model tutor.